Our presentation was about anchoring cytokines to the collagen of basement membranes in tumors as a treatment for it's an immunotherapy treatment for cancers. And as an intro, cancer immunotherapy it's been around for a while. It's mainly been around since the 80s, and it originally started with monoclonal antibodies to certain tumors. And recent advancements in immunotherapy, like CAR T cell therapy, which was actually developed at Penn, has kind of put increasing spotlight on the field in terms of personalized immune therapies for cancer. And theoretically, cytokine treatment kind of makes sense when you think that cytokines target certain cells and molecules for destruction within the body. So if we could modulate them to target cancer cells, it makes sense that it would be an effective treatment. But it's been found that a lot of the cytokine treatments kind of lead to more systemic toxicity. So this is kind of a way to develop that treatment without systemic toxicity by localizing the cytokines to the tumor specifically by binding to collagen in the basement membrane. And the first result in this study is that they use Lumacan to bind to the tumor cells. And what they do is eventually the Lumacan would be bound to the cytokine, but here as a test, they bind it to MSA first, and they run tests. So most of these figures over here are just comparing how much MSA stays in tumor cells and the systemic circulation compared to when MSA is bound to Lumacan as well. So they found that basically all the charts over here say pretty much the same thing, is that MSA is more in systemic circulation and less in the tumors. And then Lumacan bound to MSA stays in the tumors more effectively and for longer and out of systemic circulation. So that's kind of the first step in developing these therapies. And they found that it's been pretty successful.